In this video, we're going to continue our exploration of the ticket machine class and start writing the code for it. We're going to cover a number of technical terms, and let's just refresh our memories about some of the ones that we saw in the previous video. We're going to learn more about fields, constructors, and we're going to introduce the idea of parameters and assignment statements. Both of these will be crucial for a lot of the programming tasks that we're going to do. Let's also review the kind of steps that we looked at in the previous video about learning. These are fundamental ways in which we learn. So we often learn through observation, which in a programming context means reading source code, reading code that other people have written, and then imitating what they've written. Not simply reproducing exactly what they've done, but understanding the concepts, the patterns behind what we observe, and then reproducing those patterns for our own particular context. And we thought about some of the patterns in the triangle and ship class in the previous video, and we're now going to try and imitate those patterns in creating a ticket machine class. Another aspect of observation is reading about how to program. So an obvious thing to do as part of your learning is to continue to read the course textbook, which covers in a lot more depth the material that we're going to be examining in these video lectures. And then as part of the imitation process, we'll probably find that we make errors, mistakes. It's normal with programming that will happen. We just have to reflect on those and then try again. The reflection probably involves going back and looking at what we've seen in other contexts as part of our observation, and then understanding the reason for our errors and making corrections. So what is it we're trying to do? We're trying to create a class called ticket machine, and we want at the starting point to define a single field called balance. We want to define a constructor that initializes that balance to 0. Those are the initial steps that we want to take. Now before we do that, let's just remind ourselves of what the ticket machine actually does, how it looks. So this is what we're heading towards, and we're not going to look at the source code at this point, but we're trying to reproduce source code somewhat like this. But let's at least understand what it is our ticket machine should look like once we've define the source code for them. Now in this full version of the ticket machine class, when I create an instance of ticket machine, I have to provide some input to the newly created object. And that piece of input is what's the price of tickets that this particular ticket machine is issuing. And that's a very important piece of information, because when customers insert money, the ticket machine needs to know whether they've inserted enough money to be prepared to print a ticket for them. So the idea here is that whenever we create a ticket machine object, we have to say what price tickets is that machine selling. That might sound slightly artificial, but actually it works fairly well, and will serve to illustrate the kind of things we're trying to do with this particular project. So let's live with that as a slightly artificial way of working with ticket machines, but it will serve as the basis for introducing some important concepts. So what I'm about to do is pass some information into the ticket machine object as part of its creation process. And what we say is that I'm going to pass a parameter into the constructor of the ticket machine that is being created. And as we'll see later, what that constructor will do is take that information that is passed in other words, the constructor will receive that information, and part of the constructor's job is then to remember that information within the object that's being created. So we'll see the mechanics of that and how we write the source code for that as we progress through the video. That's just something to bear in mind. That's something we're going to be working towards. We won't implement that aspect initially, but we will eventually develop the source code that fulfills that functionality. So I'm going to type the value 1000 and that information will now be passed into the newly created instance when I click OK, and we can verify that by bringing up the inspector for this ticket machine, and we can see that there's that value 1000. Now, you might say, well, perhaps that's already embedded into the ticket machine source code and it's always going to be 1000. So let's just verify that if I type a different value into that parameter, we'll get a ticket machine whose initial state is different from one that's got 1000. So this time let me say the price of the tickets issued by this ticket machine is going to be 2000 cents. Click on OK. I'll bring up the inspector, and lo and behold, now the value here in the price field is 2000. So that piece of data that I passed into the constructor when the ticket machine object was being created is being remembered by the ticket machine object. And that's an important aspect of the way that objects work. They can remember long-term information that's passed into them. They receive information in the form of what are called parameters, and we'll explore that further later on. So I'm just going to remove that from the object bench. We don't need the two ticket machines, and let's remind ourselves of the sort of things that a ticket machine is going to be able to do. It will tell us how much money a customer has put in so far. We haven't inserted any money at the moment, so if I call that method, we're shown the value is 0. We can find out what the price of tickets is. I'll call that method, and we're told the price is 1000 for this ticket machine. And I can insert some money. So this time I'll pass in 500. So again, this is what we were doing when we created the ticket machine object. We passed some data into the object so that the object could then do something with that data as part of its normal functionality. So again, 500 is what we call a parameter, and the insert money method is going to receive that parameter value and then use it as part of its functionality. And the using of that value will involve actually changing the internal state of the object, as we'll see in a moment. So I click on OK. I can bring up the inspector so that we can see what's gone on inside the object. We can see the price is still 1000, but the balance has been increased from 0, which is what it was when the object was created, to 500 as a result of us inserting 500 cents into the machine. And if I go back to that get balance method again and call that, this time instead of returning 0, it's returning 500. So again, the parameter value that I passed in to the ticket machine object has been used to change the state of the ticket machine object, and the ticket machine object is remembering the fact that its state has been changed. Now, it's important to appreciate that objects don't simply remember the values of parameters passed in, but they use that information in some way. So if I were to insert another 500 cents, I've passed 500 cents in twice. And now when I ask what the balance is, I'm told the balance is 1000. So what the insert money method has done, each time I've passed 500 cents in, it has updated its internal state to reflect the fact that cumulatively 2 lots of 500 cents have been inserted, and now the balance has increased to 1000. So it's not simply remembering the last parameter value that was passed in, it's using that parameter's value to modify its internal state in order to fulfill the functionality that ticket machines are expected to fulfill. And then finally, I can use the last method, print ticket, and because I've inserted 1000 cents into the ticket machine, which matches the price, I get my ticket printed. So this is what we're trying to build as we write our own ticket machine class from scratch. So let's remember what it is that we want to do. We want to observe and we want to imitate. And our observations are going to be performed with respect to the triangle and ship classes that we've seen before. So our starting point for building our own ticket machine class is going to be to say, what's it going to look like in its outer wrapper? If we imitate what we see in the triangle and ship classes, then we want that outer wrapper essentially to say public class ticket machine. We want there to be an opening curly bracket and a closing curly bracket. So let's see how to arrange that within BlueJ. Let's close this project and decide to start a new one. So I start a new one by saying project, new project. I need to indicate where I want this project to be created. So I need to say what location within my file system that project is going to be, and then I need to give a name for the project. I'm offered this particular location. I could use choose and navigate somewhere within my folder space in order to put the project somewhere different. I'll make do with this as a place, and I'm going to call the project my ticket machine. And what BlueJ does is give me a blank class diagram. So this is the diagram where the classes will appear that exist within a project. And we've seen lots of class diagrams so far. So what I want to do is I want to create a new class. So I go over here, new class, and I type the name of the class, which is going to be ticket machine, where the T is an uppercase T and the M is an uppercase M. I'll talk a little bit later about some of the naming conventions that we use for things like classes in Java. Just really to say first of all that we always use an uppercase letter for the first letter of all class names. So if you think back to triangle, square, circle, person, picture, canvas, ship, all of those class names had an initial uppercase letter. And that's the convention that everybody uses in Java programming. And I know that as a learner you may find it hard to follow that convention, but please do, because then your code will be a lot easier for other people to understand who are used to this convention that all class names start with an uppercase letter. So we leave this class type ticked here. You'll learn much more about these different types further on within this course and in other courses, but that's the one we want ticked. There's our class name. We want this to be a Java class, and so click on OK. And what BlueJ does is it creates us a rectangle. That rectangle is striped, which means that the class has not yet been checked by what's called the compiler. So the compiler hasn't looked at the source code to make sure that it's standard, legal Java. In fact, if I were to press the compile button, the stripes go away and we can see the message down here, compiling done, to say that the compiler has checked the source code that's inside this class. Now, you might wonder what possible source code could there be in there, because we haven't written any yet. We've simply asked for a class to be created. Now, one of the things that BlueJ does is it provides you automatically with some source code and a class definition. And unfortunately, this is not always as helpful as you might think it's going to be, because it will always give you the same source code, and that source code is really of no use to us for most of the classes that we're going to be creating. So BlueJ is giving you some what's called boilerplate code or template code as a starting point, and this is not very helpful, certainly not from a teaching perspective. So I'm actually going to throw away all of the code that BlueJ has given us. So I'm just going to highlight the whole class and I'm going to hit the delete button and leave myself with a completely blank class file. There is no source code in there at all. Now, faced with this, what are we going to write for our ticket machine class? Well, if we can't remember, we can go back to classes we've seen before, note the similarities and the common elements and the things that we're going to need in our class, and reproduce them in our source code. So we look at these examples: public class triangle, pair of curly brackets, public class ship, pair of curly brackets. We're going to write public class ticket machine and a pair of curly brackets. So let's do exactly that. Public class ticket machine, remembering to make sure that we've got the same case for the T and the M as we gave when we asked BlueJ to create this class for us. Going to start a new line. There's a little brown mark here to tell us that there's something wrong with the class. Let's not worry too much about that at this stage because we know we haven't put all the elements in that we saw with the other two classes. Let's just refer back. We need a pair of curly brackets. So back we go, opening curly bracket, start a new line, closing curly bracket, and now note that the brown mark has gone away. Now we can check to see whether we've faithfully reproduced what we should be imitating by pressing this compile button, and we get this lovely message down the bottom which says class compiled, no syntax errors. That's always going to be our aim. We want to know that there are no errors in the source code that we've written. Now, I've said several times already, errors are inevitable, so don't worry if you get syntax errors, other forms of errors. Reflect on what you've written, observe what the error message is telling you. The error message may be helpful. Seek to correct. If you can't correct from your understanding already, go back and look at some other examples. So do the observation and then do the imitation and then have another go. We're just going to be going through that cycle again and again and again. So we've now got a very bare bones ticket machine class, and I can actually close that source code. We see there are no stripes on here, and I could actually create a ticket machine object. Now notice that when I do this, I'm not asked for any price, I'm simply asked to give a name to the object that I'm creating. And I'm not being asked for a price because we haven't written a constructor yet, and we haven't written any source code that would cause us to be prompted for the price of tickets. We haven't got that far yet. I can even bring up an inspector, and what the inspector tells us is there are no fields. So that's going to be the next thing we need to work on in developing our source code. So let's reopen the class. Let's go back to the examples that we've seen before and look at the kind of things that we might be writing inside our class definition in order to define a balance field that's going to be able to store the cumulative amount of money that a customer inputs before they print their ticket. So we've got two examples on the slides that we can look at and work with, and of course you can go and open up these projects and look at the source code there and find other elements of those classes that might help you doing this. So what we see inside the triangle class is a field called private string color. The field is called color. It has data type string. And the other elements, private and semicolon, are things we're not going to worry about the details of at the moment, but we'll simply imitate those. We'll imitate them without necessarily understanding what they mean. That doesn't matter. That's legitimate until we get to the point where we can understand those reasonably. So triangle has a field called color of type string. Ship has a field called speed of type int. And we need to think, well, which of those is closest to the idea of a balance field in our ticket machine class? Is that balance going to be storing a bit of text, a string, or is that balance field going to be storing a numerical value, an integer? And I hope you can appreciate that this ship example is the closest to the balance field that we want. So we want to define ourselves a field called balance. We want it to have the data type int, and we're going to add those other elements, private and semicolon, just as we see here. So let's go to our source code and start typing that. Now all of this happens in between those two curly brackets. So I move the cursor The BlueJ editor helpfully gives us what's called indentation. It moves the cursor in a little bit to show that anything we type now is going to be part of the body of the class. And I'm going to start typing private. I typed the wrong word there, that doesn't matter. I just do some editing, private, then a space, then the word int, and then the word balance. And to see whether I've got that right, I'm going to press the compile button. Now, I get a brown mark and I get a little message down here saying error found in class. Press Command K or click link on the right to go to the next error. So I'm going to click the link on the right and I get a little pop-up saying there's a semicolon expected. What does that mean? Well, if we go back to the slides, I forgot to put the little semicolon symbol after the name balance, name of the field. So I should easily be able to correct that. I'll position the cursor there, put a semicolon in, the brown mark goes away, I can press compile, and again, no syntax errors. So things are looking good again. Let's create a ticket machine again. Let's bring up the inspector. And now we can see that the field that we've just defined, called balance, appears within the inspector, showing us that we've successfully added our first field into a class definition. Now, one of the things we notice is that this field has the value 0 in it. So the next step that I'm going to take, strictly speaking, we wouldn't need to do in all cases. But I'm going to take the next step anyway, because I think the principles of what I'm going to show you are important principles. So we now know how to define a field. And if we wanted other fields like price or the total amount of money accumulated through the day, I hope you'd be able to add those in a very similar imitative form immediately after the balance field. But let's move on to the constructor. Let's remind ourselves what a constructor looks like and what it does. So here, after the definition of the speed field, we've got public ship and then a pair of round brackets, then an opening curly bracket, and then what we call an assignment statement in which we are assigning the value 5 to the speed field. And then there's a semicolon and a closing curly bracket to mark the end of the constructor. So in the previous video, I noted that a constructor is always called the same name as the class. So let's see if we can imitate a constructor inside the ticket machine class that we're building. So we want to use the word public, the name of the class, and then we want that pair of parentheses. And now I'm going to write my pair of curly brackets here, and at the moment not worry about putting anything inside those brackets. Again, I'm going to press the compile button. I'm going to check to see whether everything I've done is okay. Compile, class compiled, no syntax errors, fine. I can even go so far as to say let's create a ticket machine again. Let's bring up the inspector. Things are still looking good. Our balance is set to be 0. Now, in those two examples of ship and triangle, what I've done is to write what's called an assignment statement to the field inside. Now this is a way of saying the initial value of this field, I want to be this value every time a triangle is created. So because I want to be fairly imitative in the writing of the ticket machine class, I'm going to do the same thing inside the ticket machine class. I'm going to initialize the balance field to 0. So let's do that. So I'm going to write balance, which is the variable I want to initialize. And then I write this symbol, and then I write 0, and then I put a semicolon on the end. Now, What do we call this symbol? It's tempting to say this is the equals symbol or the equal sign, because that's what we've always called it all the way through school mathematics. We would say balance equals 0. Now, I want to say something that's potentially controversial and say I don't want you ever to call this symbol the equals symbol when you're writing Java. Because if you think of it as being an equal symbol, then I think it's quite likely that you can misunderstand what is going on here in an assignment statement. And what I want you to call this symbol is the assignment symbol. Because what it means in a programming language is different from what it means in mathematics. In a programming language, the assignment symbol means take the value on the right hand side and store it into the memory location whose name is on the left hand side. So let's say a little bit more about what a field is. What we have here, the word balance, is what we call a variable name. So fields are variables. What a variable is the name for a memory location in the memory of the computer. And that memory location can store a value. So what the assignment symbol does is it says whatever value is on the right hand side of this symbol is now to be stored into the memory location named by the variable on the left hand side. So this takes the value 0 and it stores it into the memory location called balance. Now, to show you a little bit more about that, let's see what we could do. And this is completely artificial. This is not what we would do in a ticket machine as normal, but I want to show you the effect of what's on the right hand side with what's on the left hand side. So on the right hand side of that assignment symbol, we can write mathematical expressions. So I could write 3 plus 4 minus 10. And what will happen at initialization time of a ticket machine is that this mathematical expression will be evaluated. So 3 plus 4 is 7, 7 minus 10 is minus 3, and the result of that expression will be that the value minus 3 will be stored into the variable called balance. And I can show you that that's true by selecting compile, creating a ticket machine object, bringing up the inspector, and lo and behold, the value of that balance field when the ticket machine is created is minus 3, because the arithmetic involved in this arithmetic expression was performed. The result was minus 3. Minus 3 is stored into the memory location that's called balance. Now clearly we don't want minus 3 to be stored in ticket machines. We want the value 0. So I'm going to make it a principle that for every field that I've got defined inside my class, I want to have an assignment statement where on the right hand side is written the initial value of that field. And even though Java would automatically initialize these fields to be 0 anyway, I'm still going to write that because I think it's a good style to get into, of writing an assignment to every field inside the constructor, so that the reader of my class knows that this is the value I want and I haven't forgotten to initialize one of the fields to something different. So let's compile, because I just made an edit. Everything's looking good so far. So what we've got is we've got the outer wrapper of a ticket machine. We've got a field called balance that can store a numerical value, and we've assigned 0 to the ticket machine's value initially. Let's think about extending this, and again let's be imitative. So let's add another field, and it should be easier to add another field this time because we've already got experience with adding one. So now I want to define a field that can store the price of tickets. Price is a numerical value, so I go through exactly the same steps. Private, int, price, not forgetting the semicolon. Inside the constructor, I want to write an assignment to that price field. And this is where things get a little bit more tricky. What value do I want that price to be? Now we saw when I demonstrated the full version of the ticket machine that creating the ticket machine requires the user to input a parameter value to say what price they want this particular ticket machine to have. Now that's another step that we'll take in a few moments, but for the time being let's just look at initializing the price to a fixed value. Let's say that every single ticket machine that we create will sell tickets whose price is 1,000 cents. And we're doing this really just to get us an idea of whether we're going about things the right way. Have we defined this field correctly? Have we initialized the field correctly in the constructor? So again, I'll compile, everything's all right. I'll create my ticket machine, bring up the inspector. Fine, balance is 0, price that we just added is now 1,000. So everything's looking good. We're at the point where we can comfortably add as many fields as we want, and we can comfortably initialize those fields to any explicit value that we want, potentially involving arithmetic if we want something more complex on the right hand side of an assignment symbol. But now let's do this properly. Instead of creating a ticket machine and not being asked for a price, I want, when I create the ticket machine, to have to provide extra information that is the price of tickets or the cost of tickets for that ticket machine. How do I do that? Well, in order to do that, I need to introduce you to another type of variable. So I've already mentioned that these fields define variables, one called balance, one called price. In between these parentheses that are part of the header of the constructor, we can name further variables. And if we name further variables within those parentheses, then that will mean that when a ticket machine is created, we will be asked to supply data values that those variables have to be set to. Now the variables that we're defining between these parentheses are not called fields, they're called parameters. And the idea of a parameter is that it receives some information, some data from outside, from another object, or if we're a human interacting via the BlueJ environment, via a human. So what we want ticket machines to receive is the ticket price, or the cost of tickets that this machine is to issue. So what we want to receive is a value of type int. We want a numerical value. I need to think of a name for this value, and so I'm going to write a name cost. So the idea here is that when a ticket machine is created, we will have to provide the cost of the tickets. Now at this stage I'm not going to do anything with that cost variable. I just want to check to make sure that I've written the Java correctly, and the way to do that is to write compile. I can close, and now let's see what the effect of doing that is when I create a ticket machine object. So this is different. This is something like we saw with the full naive ticket machine project, but it's not something we've seen so far with our own version of the ticket machine class. We are now being asked to say, how much do you want these tickets to be? So we want to put a value in there. So let's put the value 2,000 in there. We want this ticket machine to sell tickets at a cost of 2,000. Let's bring up the inspector. Now what we see is that the price is still 1,000. It's not 2,000. But we want this price field to be storing the value 2,000. In other words, we want the price field to be storing the value that we passed in via the parameter. So how can we make that happen? Well, we can make that happen by making a change to this assignment statement. So remember, this assignment statement is what causes a particular value to be stored into the memory location named price. Now, what we want stored into that memory location is whatever number was passed in via this cost parameter. So at the point where the constructor is being executed, that cost parameter contains the value 2000 or 3000, whatever was passed in from outside. So this cost parameter receives a value that we then want to then store into the field called price. So the way that I cause that to happen and for the price field to store the right value is, instead of writing 1000, I write cost. And what that says is whatever value is currently stored in the cost variable is now to be copied into the memory location known as price. So it's a copying of data from what's on the right hand side variable to what's in the left hand side variable. This copying process doesn't change anything about cost. Cost will still contain the value that was passed in, but that value is also copied into the memory location called price. So let's check that I got that right. I'll do compile, close, create a ticket machine, type 2000 in, and this time when I bring up the inspector, lo and behold, 2000 is now stored in the memory location known as price, because I've copied that value that was passed in via the parameter now into the price field. And that's quite a lot to take in, but we've covered a lot of important and fundamental ground. We've looked at how we write the external wrapper of a class. We've looked at how we define fields, those 4 elements: private, a data type, a variable name, a semicolon. We've looked at how to write a constructor which has the same name as the class, has a pair of parentheses. Potentially between those parentheses we can define one or more variables, which are parameters. And then inside the body of the constructor we've seen how to initialize these fields, either with literal values coming in. We've also seen an example of an arithmetic expression, but also, particularly importantly, the fact that a parameter value coming in can then be used to initialize the value of one of these fields. And what that means now is that every ticket machine we create will be asked for what price the tickets are, and each individual ticket machine will then charge that particular price for the tickets that it issues. So just to finish off, there are a few things I want to review. We've seen words like public and private and class and int. Java calls these keywords or reserved words. So there's special words that are part of the Java language that you will see over and over and over again. So when you're observing source code, take note of where words like public and private and class and int are used, because you will see them a lot. These words are always entirely lowercase. You never see capital letters in Java keywords. We've looked at fields, that they store values for an object. Another word for those variables that are defined as fields is instance variables. And fields define the state of an object, and we can use inspectors to view that state. And then we looked at constructors. Constructors are used to initialize an object. They have the same name as their class, and there's a very close association with the fields. In the code that I write, and I'd like to see you do the same thing, I'd like to see an assignment statement for every single one of the fields that you've defined inside the body of the constructor, even if you are initializing a field to have the value 0, because that makes it clear that you've thought about every single one of your fields and what initial value that it should have, and it means you avoid missing something out. And then we've seen that parameters are a way for an object to receive data from outside itself, and those parameter values are often used inside both constructors and methods. We'll see examples of their use with methods in the next video. And then we've seen that the assignment symbol is used to copy the value of an expression on its right hand side into the variable named on the left hand side. And I'll just remind you that we never call that assignment symbol equals within this course, because if you call it equals, I think it'll create some confusion about exactly what it means. It's not the same as equals in mathematics. And then one final point is that when we decide on the names for variables, it's a good idea to choose names that reflect their purpose within a program. So I've used words like price and cost and balance, course, speed, X position, Y position. They all clearly express what that variable is being used for. Try to avoid abbreviations like W, T5, ABC, where you can't think of a name. It's not helpful to anybody reading your code, and it's good to get into the habit of picking meaningful names. So class bodies contain fields, constructors and methods. In the next video we'll start looking at what methods look like and how to write those. Constructors initialize objects, particularly the fields of the object. An assignment is used to store a data value into a variable, and a variable is the name for a piece of memory.